All the physical quantities in this universe have dimensions. Why? Because a physical quantity is something that can be measured. For example, length has the dimension of L, mass has the dimension of m, time has the dimension of t, and so on. In this video, we will see any physical quantity can be expressed as a dimensionless number, or more precisely, a bare number that doesn't depend on units. That means a quantity of dimension 1. And this is called non-dimensionalization. So, when you express a quantity without any physical unit, it becomes a dimensionless number. Non-dimensionalization has many advantages. For example, when an equation is non-dimensionalized, it doesn't change if we change our coordinates or units of measurements. Let's see how to non-dimensionalize a differential equation. This is the equation of motion of an object launched vertically from the surface of the earth, where y is the height of the object at time t, v0 is the initial velocity, r is the radius of the earth, and g is the gravitational acceleration. The main concept of non-dimensionalization is to separate the variables and parameters of the equation and express the variables in terms of parameters. Guys, if you don't separate the variables and parameters, you will get confused. So this is important and the main thing here. And it is easy. First, identify the dependent and independent variables of the equation. All the rest are parameters. In our equation, y, t are variables. Y dependent variable, t independent variable. Y has the dimension of length, that means L. T has the dimension of time, that means t. Now the parameters. G has the dimension L per t square, R has the dimension L, V0 has the dimension L per t. Now express the variables in terms of parameters. Let's see how. First, dimensionless time. Tau equals t divided by a, where a is an unknown until we find the value. Now listen carefully. Small letter t has the dimension t. Look at the parameters list. We can combine r and v0 to get the dimension t. This t and t will cancel out each other. In this way, we will get dimensionless time tau. Tau equals t divided by r over v0 equals v0 into t divided by r. Second, dimensionless height. Capital letter Y equals small letter y divided by b, where b is an unknown until we find the value. In the same way, we can express y as a dimensionless number. Small letter y has a dimension L. Look at the parameters list. Again, r has also the dimension of L. So, capital letter y equals y divided by r. This is how you non-dimensionalize a quantity. The rest is easy. Put the values of small letter y and t into equation 1. So after some calculation, we get this equation, where capital letter y and tau are dimensionless. So take everything else on the right hand side of the equation. The whole equation is now dimensionless. So g into r divided by v0 square will be dimensionless too. Let's call it alpha. This is the non-dimensional equation we wanted, where capital letter y equal small letter y divided by r, tau equals v0 into t divided by r, and alpha equals g into r divided by v0 square. These three quantities are dimensionless quantities. This is all for today. We'll talk more about dimensionalization later. See you guys. Bye bye.